Welcome back. Today we are going to be working on the Arduino Starter Kit Project 11, the crystal ball, if you will. If you've ever seen a magic 8-ball where you shake it and it gives you answers, we're doing something like that today. Now, you might ask, how do you make something like that? Well, what parts would you use that you've used before? What's a part that is happening with shaking or movement? Right? The tilt sensor. We used the tilt sensor a few times in previous projects. We used it for the digital hourglass off the top of my head, and we could use it as like a shake mechanism for a crystal ball. Now, what I'm going to do here is just quickly go over some of the problems you might have, because this project, I mean, at this point, you're getting comfortable with things. Also, the Arduino provided video with the demo gives some good information. If you're looking what specific pins on the LCD do, you can consult the book or the video. It's very great. So I'm only going to do some troubleshooting and a little bit of fun here. So let's get at it. Now, if you look down here, I've got the project wired. The first thing you're going to do, I want you to take a look at a couple things here. Make sure your tilt sensor is pointing up with the arrow like it asks. The next problem you could have is using the wrong resistors. So make sure you're checking the proper resistors. Another problem that is pretty common here, the LCD sits very well. There's no problem with how the LCD display fits. The problem was with the potentiometer, as usual. Of course, it seems like every time the problem's the potentiometer. Now, once again, I'm going to show you how I kind of hacked it. If you look up here, you can see I actually jumped to the second side of the board and ran the 1 to the 3rd pin here from the potentiometer, which controls the contrast. That's the contrast pin of the LCD display. I ran that on a separate side of the board, that one in middle pin, and then I also ran power and ground here. So instead of putting this potentiometer all on this side, it was too crammed. I put it on this side and spaced it out and ran that to the contrast button. The other thing is that still, if this goes shaky, the display will die. So if you're having a problem, always kind of make sure your potentiometer is flush and maybe even press down on it to get a good connection. If you're getting a wobbly display or things aren't working, it's normally going to be the potentiometer in this time. It's normally the potentiometer or this facing up or the wrong resistor. This sits pretty great. See, look, I'm not connected, but if I wobble it, there we go. You can see that. All right. Sorry, there we go. If I wobble it, right, on, off, on, off. If I want to change the contrast, I have to kind of push it down, and I can make the contrast dimmer or higher. And you should be able to do that when you demo it for me. And of course, you should be able to make new answers with the knock lock. Not so good, says the knock lock. Now, what can I tell you? Well, a couple things to know about this project before I let you go. Obviously, you're going to go write the code and verify it. And it's quite a bit of code. It's no laughing matter here. Let's see what we got. You have about 52 lines of code at least. I've done some explanations in mine. You can see here, right? So I've added more comments in mine. But I just added more spaces. If you need the code, I can help you out and get you that if you're having problems. And you can always send me a screen capture of any code problems. We've been doing pretty good working through that, or you just show me it, obviously. But let's do a little talk about the project. Obviously, the tilt sensor here works as a switch. You could actually put a switch there and switch it, and it would change the result. This is just connecting every time you tilt it, which acts like pushing a button, right? So this is just used as a switch. It's run to ground. The potentiometer is used to control contrast. There is 16 pins on the LCD display, and this is our new component. Also, we're using a library, right? We're using the LCD display library, and a library is a bank of code built for one part. So you don't have to type all the code needed to make the LCD display work. You use the LCD library, insert that, and all of a sudden, you've got a whole working LCD display that you can just send commands to. So we're going to use the LCD library to make this part communicate a little bit better. What else is really important? Well, that LCD display, it has a couple. One of the problems that students have is that these pins are labeled 1, 2, 3, 4, 5, 6, up to 16. And then these slots are labeled 1 all the way down to 30. So they kind of work against each other. So be careful you're using the right pin number and the right row number. That can get very confusing in the diagram. So make sure you've put everything in the right way, and you know that these start at pin 1 to 16, but this goes from pin 1 to 30. We can talk a little bit, right? Obviously, there's a ground and power pin. Did you know that if you take a magnifying glass, you can actually read what all of these pins do right down here? It's fine printed. So some of the things that you should look out for are the ground and power pins, and ground and power on the bottom side as well. 4, 5, 6, and 7 are used as data pins. That's where you send character data to the LCD. Character, I mean like text, like characters, alphabet, numbers, things like that. Character data going to there. There's something called an enabler pin. There's something called a read-write pin. The read-write pin determines whether this will be an output or an input, sort of. And V0 right here coming off of the potentiometer, off the middle pin of the potentiometer to right here to V0 is what we call the contrast control for this. And that's obviously V0, depending on how much voltage it gets, determines how bright or contrasted the display is. There we go. Look at, there's that potentiometer problem. So there we go. Got it sitting pretty. So I'll do a little bit of demo for you, but what I'm expecting from you is to write the code, build the sketch, upload it, and we're going to demo it together. One thing, not saying you should, but you could put anything for a comment from the knock log. Technically, you could write whatever you want there. Please don't do anything too crass or anything, but you can make some funny jokes and things like that, because the text included in our booklet is just generic Magic 8-Ball kind of answers, but you can write whatever you want. So have some fun with that. You can maybe play a prank on somebody or things like that, or make it like look like it's specifically tailored for a certain person. You can change the display things that will show up. Make sure that the characters are the right limit, because you're only limited to 2 rows of 16 for text in this, obviously, because of the display we're using and the code we've used with the library. But let's see here. Let's take a little demo. I didn't write any funny stuff, unfortunately. But let's see. Will we have... Well, let's see. I'll reset it first. Ask the crystal ball. All right. Will we have beautiful weather coming up? Outlook, good. All right. Is Mr. Sitnick the greatest teacher ever? Oh, no. No. I hate this project. It sucks. Never mind. You don't have to do it. Kidding. Just doesn't think I'm a good teacher. Nothing personal there. 8-Ball. All right. Anyway, have a great day. I'll give you a few days because there's a good amount of code and a good amount of wiring. So this will be a few days to work on this. No rush, as usual. Take your time. Contact me if you've had any problems. I'm looking forward to seeing you play around this and what you can come up with. It has been a slice. And one thing I need you to do is, for the next project, we are working on something called a knock lock, where you're going to make a certain pattern and a motor will turn so you can open a box. It would be almost like a digital safe in a hotel room. The same kind of mechanism and the same kind of code-ish. Instead of using a keypad, you use a secret knock that a piezo can identify, or piezo can identify. It can sense the knock and tell the code, this is the correct knock, open the box. You'll put a little motor here with an arm that simulates being open or locked. So if you could find a small box, this shoe box is actually overkill. It's kind of too big, but if you could find a box even half the size of a shoe box, and it doesn't have to be as deep either, so about a quarter of this size would even work, just a small little box with a flap that opens up like this, right? There's that flap here. So before you come in for the next project, or you're working on the next thing, try and find a small box like that that you can hack, that you can glue a motor into or sticky tack a motor into, wire up, hide your Arduino in. You can see on this one, the Arduino actually got hidden inside the box here. The wires hung up here, and the motor stuck out. If you're curious, look ahead at the next project and see what we're going to do, so you can determine kind of what kind of box you want to bring, because everybody's going to make their own custom knock lock. So that's the kind of a looking ahead. Have a great day. I've talked too much already, so we'll see you soon. Take care.